Welcome back to my channel, Physics from 5 KSSM. We continue Chapter 2 Pressure on topic 2.4 Pascal Principle Part 3. So in this video, I will discuss the force learning standard, solve problems involving Pascal Principle in daily life. I will discuss some examples regarding Pascal Principle, and then I will discuss on Formative Practice 2.4. Okay, look at the first example. Figure below shows a hydraulic system. Calculate A multiplying factor, B output force F2. So this is hydraulic system. The smaller area of piston, this one is input piston. The larger area of piston, this is output piston. So first we can list down all the information given. From here is already stated clearly. F1 is 12 Newton, A1 equals to 10 cm squared. The output force F2 we need to determine, and then the surface area of second piston A2 is 50 cm squared. Okay, so multiplying factor actually is ratio of area of the second piston to area of the first piston, meaning A2 divided by A1. So from here we get 50 cm squared divided by 10 cm squared. Thus we get 5. No unit because the unit already cancelled. So multiplying factor is 5. For B, the output force F2. According to the multiplying factor is 5. Thus, the output force produced actually is 5 times bigger compared to the input force. Thus, F2 equals to 5 times 12 equals to 60 Newton. So I hope you know how to relate between these two questions, A and B. Okay? Because from the formula that we get from the Pascal principle, F2 is equals to A2 divided by A1 times F1. So A2 divided by A1 actually is multiplying factor. So you just can multiply straight away from here. Okay. Number 2, a technician intends to design a hydraulic brake system for his bicycle as shown below. The input force that a cyclist is able to exert is 60 Newton at the input cylinder, which has cross-sectional area of 0.80 cm squared. What is cross-sectional area of the output cylinder? That will produce braking force of 840 Newton. So we can list out now all the information. So the input force we mark as F1 equals to 60 Newton. For the A1 is equals to 0.8 cm squared. F2, 840 Newton. We want to find the value of A2. So use the Pascal formula. F1 over A1 equals F2 over A2. So we just substitute all the values. Before that, you need to check the unit for area. Okay, here cm squared. So meaning we can get the area for the second piston is also in the same unit, cm squared. Okay, just substitute all the values, then we get A2 equals to 11.2 cm squared. Okay, the third example, this is a simple hydraulic system. So this figure shows a hydraulic jack whereby an elephant of weight 40,000 Newton is placed on top of the larger piston. A, what is the minimum force needed to the smaller piston in order to lift this elephant? Okay, we look at the area for the input piston is 0.4 meter squared. For the second piston is 6 meter squared. So we are going to use Pascal formula. Information given, the output force for F2 is 40,000 Newton. Area of the first piston, A1, 0.4 meter squared. area of the second piston, the output force, A2 equals to 6 meters squared. We want to find what is the output force. So the output force is equals to minimum force needed to lift the elephant. Okay. So this case, we want to find the minimum force needed to the smaller piston, meaning input piston or input force. Okay, F1. We want to find F1 for the first piston. So meaning the output force is already given 40,000 Newton. Okay, so we just apply the Pascal formula. So from here we get F1 over 0.4 equals to 40,000 divided by 6. Thus we get F1 equals to 2,667 Newton. So with this smaller value of force, it able to lift up 40,000 Newton of elephant. Okay. So what is the transmitted pressure? So for this hydraulic system, we have discussed before, pressure transmitted equally throughout liquid, meaning pressure acts at the first piston or input piston is equals to pressure that acts at the second piston or output piston. So you can choose to use any piston, you have enough information. So you have the value of F2 and A2 given. Try to avoid using the value that you calculate, okay, for the second time, because if the first value here is wrong, then your next answer also will become wrong. So we use the value F2 and A2 to calculate the pressure. So P equals to F2 over A2. Thus 40,000 divided by 6. We get 6,667 Pascal. Meaning at the input piston, 6,667 Pascal. At the second piston, also 6,667 Pascal. Okay. Okay, let's look at formative practice 2.4. You go and try to answer this question first before you come back to check the answer. Okay, number 1, state Pascal principle. So according to Pascal principle, the pressure applied on an enclosed fluid is transmitted uniformly in all directions in the fluid. So you can use the word liquid also can. For example, Pascal principle states that pressure applied on an enclosed liquid is transmitted uniformly in all directions in the liquid. Also the same. Okay, number 2, describe how hydraulic machine can achieve force multiplication by applying Pascal principle. So this one we need to use the formula, the Pascal formula, F1 over A1 equals to F2 over A2. So this one will produce force on the second piston or output piston, F2 equals to ratio of A2 to A1 multiply F1. So from here, for the hydraulic system, area of A2 is greater than A1. This one will cause ratio of A2 to A1 is greater than 1. Thus, what happens to the force produced? So the output force F2 is greater than F1. Therefore, a small input force on the small piston is multiplied to become a larger output force on a large piston. So we can, if you want to increase the output force, meaning applying Pascal principle, so you can increase the multiplying factor, meaning increase the area of A2, the second piston. Okay, so you can control the amount of output force can be produced by using this multiplying factor or the ratio of A2 to A1. Okay, number 3, in a hydraulic system, an input force 4 Newton acts on piston With surface area 0.5 cm squared, calculate output force produced on a piston with surface area 6.4 cm squared. So apply Pascal formula. Thus we get F2 equals to 6.4 divided by 0.5 multiply 4. Thus we get the output force equals to 51.2 Newton. Number 4, a pupil has a small shrink with piston of diameter 1.5 centimeter. The pupil intends to construct a hydraulic system that can multiply force from 6 Newton to 72 Newton. What is diameter of a large shrink that is required for this hydraulic system? So actually, if you want to find the diameter of a large shrink, meaning it relates to area of the piston. Okay. So Pascal formula. Multiplying factor A2 over A1 actually equals to F2 over F1. We just rearrange the formula here. Thus we get A2 over A1 equals to 72 divided by 6 equals to 12. The multiplying factor is 12. So we can relate A2 to A1. A2 equals to 12A1. The question here needs you to find diameter. Okay, so here is the area. Okay, so the cross-sectional area of a cylinder or the shrink is a round or circle shape. So we need to apply the formula for area of a circle, which is D is the diameter. The formula for the area is pi r squared, radius. Radius equals to D divided by 2. Okay, so pi D divided by 2 squared. It produces pi D squared divided by 4. So this is for the second piston. We want to find the diameter of large shrink. So pi D2 squared divided by 4 equals to 12 pi D1 squared divided by 4. This is for the smaller shrink or smaller piston. Okay, so what we get, we can cancel, like pi here we can cancel, 4 here also can be cancelled. Thus we get D2 squared equals to 12 times 1.5 squared. So you just calculate this one using calculator. So we get D2 equals to 5.2 centimeter. Thus, diameter of the large piston equals to 5.20 centimeter. So for this topic, I will stop here, meaning we have discussed about Pascal principle. So you can try more examples on this so that you can understand better. Okay, that's all.